Let's discuss something very interesting, and we are going to talk about surds which you already know, right? Something interesting about surds. Well, the surd is something which we know, right? Root 3, 2 root 3, minus 2 root 3, all of these are surds. We know what is a surd. Nth root of a, any expression given in the form of nth root of a is said to be a surd. We know if it satisfies three conditions which we have learnt, where the order n is a natural number greater than 1, the radicand a, that is the number which is written within that radical sign, that a is a rational number greater than 1, and the entire expression, that is nth root of a, is an irrational number. So based on that, we know that root 3, 2 root 3 and minus 2 root 3, they are surds. We are going to learn something interesting about them, right? Look at this. Now when you say root 3, it's only one term there, right? It's a single term what we have there. So when you look at 2 root 3, it is only 2 into root 3. That means it is again only one term, one single term there. When I say minus 2 root 3, it is minus 2 into root 3. That means again it's a single term there. So when we have expressions here which has got only one term, obviously we'll call it as monomial, and since they are surds, we can say that these are monomial surds, isn't it? Well, so that's very easy. So if you have something called as monomial surd, you will start thinking, what's a binomial surd? Do we have something like that? Yes, we do have it. Yes, we are going to discuss that too. Now observe this. 2 root 3, is that a monomial surd? Yes, that's a monomial surd which we have. Now look here, what have we done here? Now that's a binomial surd. That's the query which you have in your mind. Why it's a binomial surd? Look, there are two terms, because we have separated these two terms using the operator plus, isn't it? Yes. Now there are two terms, one is 2, the other one is root 3. So one thing is, it is a binomial, yes, because it has got two terms. That's very clear. Now, but is it a binomial surd? Yes, for that, remember, out of the two terms, at least one term has to be a surd. And we know that here, this term, that is root 3, is a surd. That means we know this is a binomial surd. So, when do we have a binomial surd? What is said to be a binomial surd? We know there has to be two terms, yes. And the second condition is, at least one of those two terms has to be a surd, right? That means both the terms can be surds. We can have root 3 plus root 5, that is nothing but it's a binomial surd, right? So we have understood. So we have understood what is a binomial surd. Let's have few examples of binomial surd. 1 minus root 7, yes, it's a binomial surd, because we know there are two terms and one of the terms, that is root 7, is a surd. Root 5 plus root 7, yes, that's a binomial surd, because there are two terms and here both the terms, root 5 and root 7, are surds. Then the next example you see, that is 2 root 6 minus 7 upon 5. You will see here, what do we observe? Yes, it's a binomial, and one of that term, right, that is 2 root 6, there is a surd. Then we have the last one which you see there, root 5 plus root 3, that's again a binomial surd. So these are examples of binomial surd. Now why are we discussing this? Why we discuss a monomial surd? Why we discuss a binomial surd? We're going to discuss something very interesting fact about it. Now what happens here is, let's say we have expressions like this, that is 1 upon root 3, 1 upon root 5 plus root 7, 1 upon 3 minus root 7. Now when you look at these expressions which are given to you, in all these expressions you will say that the denominator is a surd. In the first example, 1 upon root 3, the denominator is a monomial surd, and in the next two examples you can see that the denominator is a binomial surd. But why are we discussing this? Because when you are doing sums in topics like surds and few sums when you do in trigonometry, the final answer, when we end up getting like this, right, where the denominator is irrational, actually we need to make it rational. So in those sums, we have to keep the final answer in such a way that the denominator is rational. That means your denominator, if it is irrational, we need to make it rational. So you are going to have the denominator either as a monomial surd or we will have it as a binomial surd. So we need to learn how to rationalize a monomial surd and how to rationalize a binomial surd, so that whenever we have sums like this, we will be able to solve it. So the objective is clear. Why are we learning this? So now let's discuss. Let's start with a monomial surd. So I give you a monomial surd. Now this is root 2. Is that a monomial surd? Yes, it is a monomial surd. We know that. The question is how to make it rational. How do you make it rational? It's very simple. If I multiply root 2 with root 2, what do we get? Now root 2 into root 2. That means I'm multiplying the same irrational number there. Right? So root 2 into root 2. What is that? Root 2 into root 2 is nothing but 2. Wow, we got 2. What is 2? This is rational. That means by multiplying root 2 with root 2, we have made it rational. Isn't it? That means we can say the rationalizing factor for root 2 is nothing but root 2. Isn't it? So we know now if we have root 2, to make it rational, we have to just multiply by root 2. Let me take another example. 2 root 2, that is again a monomial surd, isn't it? Yes. So 2 root 2, you'll say here, in this surd, 2 which is there, it is already rational. Only the irrational factor there is root 2. To make that rational, you'll say again multiply by root 2. So multiply by root 2. So 2 would remain as it is, right? Then root 2 into root 2 gives you 2. So what do we get? The final answer after multiplying, what we get is nothing but 2 into 2, that is nothing but 4. So now here the product is 4, which is again a rational number, isn't it? That means we can say, right, the rationalizing factor for 2 root 2 is nothing but it is root 2. Now let me tell you one very important fact about this rationalizing factor. Now the rationalizing factor for this, the second one which we took, we can take 2 root 2 into 2 root 2. That means 2 root 2 can also be a rationalizing factor. If you multiply that, again what you're going to get is going to be a rational number. Right? Forget, I'll give you one more example. Instead of root 2, even if I multiply this by root of 8, still you will get rational. Why? Because root 2 into root of 8, it will be root of 16, and root of 16 is nothing but 4. So 4 into 2 finally will give you 8, which is again rational. That means what I'm saying is that whenever we have a monomial surd or a binomial surd, which you're, right, the rationalizing factor which you have is not going to be unique. It can be different, right? But the easiest one, what we are doing right now when discussing, is the one which is very easy. Now, did you understand? So the rationalizing factor is not unique. It can be different. Is that clear? Okay, beautiful. Let's go ahead and let's discuss something more. And as I said, it can be vice versa. For example, for 2 root 2, the rationalizing factor is root 2. For root 2, the rationalizing factor can be 2 root 2. Isn't that easy? Very easy, right? Okay. So I'm going to give you certain surds, and you have to tell me the rationalizing factor for it. And when you multiply by that rationalizing factor, what is the rational number which we obtain, right? Let's see that too. So the surds are there in front of you: minus 2 root 3, 10 root 5 and 6 root 11. So you'll say minus 2 already rational. So what is better? Only that root 3. So just multiply by root 3. Check. Minus 2 would remain as it is. Root 3 into root 3 is 3. So what do we get? What is the product we get? It is minus 2 into 3, that is minus 6. Beautiful. That is rational. That means root 3 is the rationalizing factor for that monomial surd, that is minus 2 root 3. Isn't that easy? Beautiful. So now it is 10 root 5. You'll say 10 is rational. Root 5 is irrational. So what do we multiply to make it rational? Root 5. Check. 10 would remain as it is. Root 5 into root 5 is 5. So 10 into 5 is 50. Beautiful. Let's go ahead. It says 6 root 11. Right? 6 root 11, you will say 6 is rational. Irrational is root 11. So multiply by root 11. So what do we get? Root 11 into root 11 is 11. 11 into 6 is 66. So by now, you would have understood that whenever we have a monomial surd, how to get the rationalizing factor so as to make it rational. So that is clear. You will say now, rationalizing a monomial surd, we know. But what is next? Yes, how to rationalize a binomial surd. Let's take that. So if you consider a binomial surd, which you can see, what is that? Root 5 plus root 3. Is that a binomial surd? Yes, because there are two terms. And the second condition is also satisfied. At least one of the term has to be a surd. Here both the terms are surd. So I'll say, what is the rationalizing factor for this? Rationalizing factor means the factor which we multiply with this so that we get the product as rational. Let's check. Let's do one thing. root 5 plus root 3, let me multiply this root 5 plus root 3 with root 5 minus root 3. So what I've done right now is, you can see I've changed the sign of one term. Root 5, its sign is plus, I've kept it as it is. For root 3, the sign was plus, I've taken it as minus root 3. So that is what I've got the next expression as, the next binomial surd as root 5 minus root 3. How did I get it? By changing the sign of one term. Let me multiply and see this. Let us multiply this too and check whether root 5 minus root 3 happens to be a rationalizing factor. It will become a rationalizing factor only when we multiply and we get the product as a rational number. So let's check. Now when you're going to multiply this, you will say it's so easy to multiply. Why? Because this expression now is nothing but it is in the form of a plus b into a minus b. And we know a plus b into a minus b is nothing but it is a square minus b square, isn't it? Yes, my dear kids. So let's solve it. So what is your a? Your a is root 5. What is your b? Your b is root 3. That means when I say a square minus b square, what does it mean? It means root 5 the whole square, right, minus b square. That means it is root 3 the whole square. Beautiful. So let's solve it. What is root 5 the whole square? Root 5 square is root 5 into root 5, which is nothing but 5. Beautiful. And what is root 3 the whole square? It is root 3 into root 3, which is nothing but 3. Solve it. 5 minus 3, how much do we get? 2. So now see, we got the product as 2, which is a rational number, isn't it? That means now we have a conclusion saying that root 5 minus root 3 is a rationalizing factor of root 5 plus root 3. And we can say vice versa also. That means the rationalizing factor of root 5 minus root 3 is root 5 plus root 3, isn't it? Beautiful. So we check this. Okay. As I said, when I took this rationalizing factor, what did I do? I changed the sign of one term. So in the first case, what I did is, I changed the sign of root 3, which was plus, I took it as minus. But you will say, we can also change the sign of 5 and keep the sign of root 3 intact. Yes, let's check with that too. That means you are saying, now let's check whether, what? Root 3 will keep it as it is plus, and the sign of root 5 will take it as minus now. So let's check whether minus root 5 plus root 3 is also a rationalizing factor. Let's multiply and see. So let's multiply this. So you're multiplying two binomials here, right? So what do we do? Right, root 5 multiply with the entire, with both the terms of the second bracket there. So root 5 into minus root 5, right, plus, what do we get? Plus root 5 into root 3. Beautiful. Further, plus, now multiply root 3 with the second bracket, with each term of the second bracket. So what do we get? Root 3 into minus root 5 plus root 3 into root 3. Beautiful. That is what we got. Let's simplify this. Let's solve each and every term here. So what do you get in the first term there? Root 5 into root 5 is 5, and the minus sign there, that means it is minus 5. Plus the second term, what do we have? Root 5 into root 3. Root 5 into root 3 is root 15. That is plus root 15. Here, plus into minus is minus, so we have the minus sign there, and root 3 into root 5 is nothing but root 15. Beautiful. Further, plus root 3 into root 3, what is that? It is 3, so we have plus 3 there. Now let's solve it. What do we get? You'll say plus root 15 minus root 15 gets cancelled. Wow, awesome. So what is left now? Minus 5 plus 3. What is minus 5 plus 3? Different signs, so we are going to obviously subtract and take the sign of the greater number. That means the sign of 5, that is minus 2. That means we got minus 2 as the product here. Now what is minus 2? You will say minus 2 is a rational number. That means we observed one more thing here, that minus root 5 plus root 3 is also a rationalizing factor for root 5 plus root 3, or we can say vice versa too. That means one thing which we observed here, whenever we have a binomial surd, to get the rationalizing factor, we have two options here, isn't it? Two options here to get the rationalizing factor. How do we get that? Very simple, very easy. What did I say? Change the sign of one of the terms, right? So what did we do? If I change the sign of root 3, which is plus, that means your one of the rationalizing factors would be root 5 minus root 3. You will say, I want to change the sign of root 5. So that becomes minus, this would remain as it is. That means the next factor would be minus root 5 plus root 3. So that means whenever we have a binomial surd now in the denominator and which we need to make it rational, you know what you're supposed to multiply. You have two options there. You just multiply any one of that to that binomial surd and we will get is as a rational denominator, rational number, right? Okay. So you're clear with this. So let me ask you a few questions here, okay? For binomial surds, let me ask you very interesting. So I'm going to give you certain binomial surds. You're going to tell me both the options, both the rationalizing factors. Let's see that. So here are the three binomial surds which I'm giving you right now. And I'm asking you, I want you to list down the rationalizing factors here. For the first one, 4 plus 5 root 2. You'll say, let me change the sign of plus 5 root 2. So plus becomes minus. That means one of the factors would be, yes, you're correct, it is 4 minus 5 root 2. So if I multiply 4 plus 5 root 2 and 4 minus 5 root 2, obviously the answer which I get, the product which I get would be a rational number. That means 4 minus root 5 root 2 is a rationalizing factor of 4 plus 5 root 2. Okay, remember that. And one more thing let me tell you. So when I say 4 minus 5 root 2 is a rationalizing factor of 4 plus 5 root 2, there's one more thing. Both of them, both the surds are also called as conjugate pair of surds. That's another term which we use. So that means if I ask you, what is the conjugate of 4 plus 5 root 2? Your answer can be 4 minus 5 root 2. It's rationalizing factor, right? That's another term which you use. Okay, so you'll say, so there is one more option. What is the other option? You will change the sign of 4. So what is that? It will be minus 4 plus 5 root 2. That means here I can say the rationalizing factor for 4 plus 5 root 2 is also minus 4 plus 5 root 2. In other words, we can also say that 4 plus 5 root 2 and minus 4 plus 5 root 2, they are conjugate pair of surds, isn't it? Superb. So let's go to the next one. What is that? Minus 2 root 3 minus root 11. You will say, let me change the sign of root 11. It is minus, so I want to make it as plus. So what do we get? What is the rationalizing factor? That is minus 2 root 3 plus root 11. That means you can say these two terms, these two surds which you saw, that is minus 2 root 3 minus root 11. For that, what's the conjugate? Its conjugate is nothing but minus 2 root 3 plus root 11 and vice versa. They are nothing but it's a pair of conjugate surds. Conjugate pair of surds. Same way, you'll say there is one more rationalizing factor. What is that? I'll change the sign of the first term there, right? For minus 2 root 3, right? I'll change that, so that becomes plus. That means the other rationalizing factor is 2 root 3 minus root 11. Isn't that easy? Let's do for the last one there. What do we get? One of the rationalizing factors is minus 4 root 7 minus root 6. The other rationalizing factor what we have is nothing but it is plus 4 root 7 plus root 6. Was that easy? As I said, these are also called as conjugate pair of surds. So wasn't that easy? So now, my dear kids, you are ready. Whenever in the denominator you have a monomial surd or a binomial surd, how to make it rational? We know that. What is the rationalizing factor we need to multiply to get it rational? We have learned that. Now that's easy, right? But you may have a query in your mind, like, I'll tell you what's that query. If you don't have, let's have it so that we discuss it. That means, if you have a binomial surd, that is root 5 plus root 3, you said, we discussed, its conjugate surd or its rationalizing factor would be root 5 minus root 3, or we can also say it is minus root 5 plus root 3. Any one of that you multiply, what we get as the product will be a rational number. But the query in your mind would be, can't I just multiply root 5 plus root 3 with root 5 plus root 3? Can't that be a rationalizing factor? Let's check by multiplying. Do we get the product as a rational number? Let's check, because that's a query in your mind. Let's check. So root 5 plus root 3 into root 5 plus root 3. It's very simple. It's nothing but in the form of a plus b into a plus b, which is nothing but a plus b the whole square. So we know a plus b the whole square is nothing but a square plus 2ab plus b square. So let's solve this. Let's open the bracket here. What do we get here? Right, so what do we get? Root 5 the whole square, that is a square, plus 2 into root 5 into root 3, that is 2ab plus b square, that means it is root 3 the whole square. Let's simplify this. Root 5 square means root 5 into root 5, that is 5, beautiful. Solve it further. So what do we get? It is 2 into root 5 into root 3, so 2 would remain as it is. Root 5 into root 3 is nothing but root 15. That means we would get that term as 2 root 15. The last term there, root 3 square, means it is root 3 into root 3, which is nothing but 3. Beautiful. So solve it. What do we get? 5 plus 3, those rational numbers we can add, and what do we get? We get 8. So finally we get the product as 8 plus 2 root 15. Now let's check this. Tell me, is this answer which we have got, is this, the product which we have got, is this rational? No, it's not rational. It is binomial. One of the term, that is 8, is rational, but here 2 root 15, that's a surd. That means that is irrational. That means we know this product is not a rational number. That means we know root 5 plus root 3 cannot be a rationalizing factor for root 5 plus root 3. So with this, your doubts are cleared, and we know now whenever we have a binomial surd or a monomial surd, how to get it rational, how to make it rational. What is that rationalizing factor which we need to multiply? Isn't that clear? Beautiful concept, right?
And yes, please do not forget to like, share, subscribe, and press the bell icon.